Greetings, students. This week we're going to be studying linear regression, and I've given you some notes here, so let's go over them together. You may ask, what is linear regression used for? Well, linear regression models are used to show or predict the relationship between two variables or factors. The factor that is being predicted, the factor that the equation solves for, is called the dependent variable. What does a regression line tell you? The regression line represents the relationship between your independent variable and your dependent variable. Definition of regression: a measure of the relation between the mean value of one variable, for example, the output, and the corresponding values of other variables, for example, time and cost. What is linear regression? When we see a relationship in a scatter plot, we can use a line to summarize the relationship in the data. We can also use that line to make predictions in the data. This process is called linear regression. Fitting a line to data. There are more advanced ways to fit a line to data, but in general, we want the line to go through the middle of the points. Which line fits the data graphed below? And you can see we have a scatter plot. And which line, A, B, or C, do you think fits the data the best? And the answer is A, because as you can see, it goes through the middle of the points. The green and the yellow lines aren't anywhere really near the points. I mean, the green line is, but you want to try to get the line to go through the middle of the points. That's a line of best fit. Using equations for lines of fit. Once we fit a line to data, we find its equation and use that equation to make predictions. Example: the percent of adults who smoke, recorded every few years since 1967, suggests a negative linear association with no outliers. A line was fit to the data to model the relationship. So you can see that my X values right here are the years since 1967, and the Y values are the percent of adults who smoke. And you can see that the line is going down. That is called a negative correlation. It is going in a downward negative direction. And the next section says to write a linear equation, which I'm going to show you in a few moments. But this would be the equation of that line of best fit that I just showed you. And I'm going to show you how to do that on the calculator. Based on this equation, estimate what percent of adults smoked in 1997. And so to estimate what percent of adults smoked in 1997, we can plug in 30 for X, since X represents the years since 1967. And in this case, from 67 to 97 is 30. So we substitute 30 in for X, and we solve, and we get 25. So about 25% of adults smoked in 1997. Here's another example. Jacob distributed a survey to his fellow students asking them how many hours they'd spent playing sports in the past day. He also asked them to rate their mood on a scale from 0 to 10, with 10 being the happiest. A line was fit to the data to model the relationship. And as you can see here, here's a scatter plot, and the blue line is the line of best fit. The X represents the hours playing sports, and the Y is the mood rating. And it looks like these are going up, which is in a positive direction, so that would be a positive correlation. And it's showing that the more hours you spend playing sports, the better your mood is, because that's also going up. And I will show you in a moment how we arrive at the equation y equals 1.5x plus 5. That is the equation of that blue line. That's the regression line, the line of best fit. And then they want you to estimate their mood rating for a student that spent 2.5 hours playing sports. And all you do is take 2.5 and substitute it in for x. And we plug it in the equation and we get y equals 8.75. Now let's go to Desmos Graphing Calculator, and I'm going to show you how to do this on the calculator. This is what we will be doing in class. So what you want to do after you pull up Desmos is you want to go to the plus sign right there, and you click on that, and you want to go down to Table. And what we're going to do is we're going to enter some values into x and y. Okay, so let's start with, okay, I'm going to do the x first, so -5, -2, and you also have to go down here and pull up the keypad. Okay, there we go. Okay, so let's do, let's see, let's do -8, -5, -2. So I'm going to do -8, and I entered it right there. And I'm going to go down here, and I'm going to click -5. These are just numbers that I'm choosing to make a graph. And then underneath that, I'm going to put -2, -2. And underneath that, 0. And right now what I'm doing is I'm just filling in the x column. Okay, and then I'm going to put 1, 2, and 5. So I'm going to put 1, 2, and 5. Now I'm going to go back, and next to -8, I'm going to put -20. -20. And I'm going to fill in my y values. Let's see, -20, -12. -6, -4. Let's see, -1, 1, and 5. -1, 1, and 5. Okay. Now, what I've done is I put some points in my XY table. There it is. Now, if you'll go over here, you'll notice that as I was putting those points in, they were being graphed. And I see a few of them right there. And what you can do is over here, you can zoom out and zoom in to see if you can view the rest of the points. So I'm going to try zooming out and zooming in just to see if I can see the rest of those points. And it looks like I can, and there they go right there. So I zoomed out, and there's my scatter plot. Okay, those are all the points that were on the table, and there's my scatter plot. Now what I'm going to do is find a regression line, and I'm going to find the equation of that line. Okay, so what we're going to do is we're going to go back over here, and we're going to push that plus sign. And you see where it says f of x expression? I'm going to push that. And I'm going to write the formula. We want to write slope-intercept form of an equation. That's the equation of a line. So watch very carefully as we do this, because we have to write it as y sub 1. If you'll notice up here, up in our table, we had x sub 1 and y sub 1, and that's what we want to write as our equation. So we're going to push y, and I need to make it sub 1. So watch what I do. And over here is a sub b. You want to push that. Go back to numeric, and you want to push 1. Now it's y sub 1. Now notice where my cursor is. It's down there at the bottom, and I need to move my cursor up again. So I'm going to go over here, and I'm going to push this key right here, and when I push that, now I'm up in the middle again, and I can work with it. Now what I want to do is I want to go back to the ABC, and I want to click on that, and I want to click this right here. It's called a tilde, and it really means approximate, and it's a tilde sign, and I want to push that, and you'll see there it is right there. And remember, y equals mx plus b, that's our slope-intercept form of a line. So I'm going to push m,